Hello, and welcome to a full demonstration of what Teleport is as a solution. Today we're going to talk about what Teleport can do to help secure and heighten the access security of your infrastructure, but also make it easier and quicker for your engineers to access all your resources today. So to start, you're going to see a how Teleport works architectural diagram. And what Teleport is an access plane. So the two main components of that access plane are the Teleport auth server and the Teleport proxy. The auth server is our internal certificate authority. This auth server integrates with your single sign-on provider, which is going to be your identity provider. This could be Azure AD, which I'll showcase to you today, but also Jump Cloud, Okta, GitHub, any of the SSOs that speak OIDC or SAML. And what the auth server does is, again, it manages those certificates. It checks your single sign-on provider for your users' metadata to confirm that they're within the right groups and they have the right attributes to roles to have that authorization to get into your Teleport cluster. The second piece of the Teleport cluster, the access plane that we have, is the proxy. This is going to be our stateless authentication gateway. Your engineers and developers can access the proxy through either web UI, which I'll showcase to you, or also the command line with TSH. TSH is Teleport locally installed into your machine, so you could use programmatic access in the command line to connect and audit your infrastructure with the 5 various protocols that we integrate with and offer. The first being Linux servers, right, your SSH nodes, Windows RDP, your Kubernetes clusters, EKS, AKS, GKE, whichever you're using, your databases, right, so your RDS databases, your self-hosted databases, and then additionally, any internal web apps that you might be hosting, for example, Grafana or Jenkins for any CI/CD pipeline tools. And then lastly, with these short-lived certificates, you can manage just-in-time access as well. For those elevated privileges, you can send access requests for temporary access to enable the least privilege model to tools like Jira, PagerDuty, Slack, Mattermost, any service desk tool that you might be using. And this API is customizable on our open source GitHub, so you can integrate this with your email, ServiceNow, any other service desk tool that enables you to have a webhook. You can send those access requests feed to that service desk operation, and you can manage them from there. In today's demo, I'll showcase integration with Slack, and I'll showcase to you all 5 protocols using the Teleport cluster. So to start, we'll go to my Teleport proxy. It's called Signal Cores at teleportdemo.com. I say Signal Core because I'm formerly in the US Army in the Signal Corps, and I just like to reference that in my demo environment. And today, as you can see, I have integrations with 4 different single sign-on providers. With Teleport Enterprise, there's no limit to how many single sign-on users you can have access to. It's just a matter of mapping those groups to the Teleport RBAC mapping that I'll show you later as well. So we'll log in with Microsoft Azure AD. And you can see I've authenticated into my Teleport cluster. So what just happened there is with Teleport, we provide you with an auth connector template for SAML and OIDC connections. This has those group values, that XML metadata from your SSO provider, and I'll show you what my Azure one looks like here. So you can see my unique value from my Azure AD Enterprise application to enable the single sign-on, and then those Teleport roles that are permitted once my user authenticates into my Teleport cluster, with the XML data here, and finally the single sign-on URL to complete the connection. In my audit log, we'll see a number of things have just happened, right? My Marco Campana, that's me, user was updated. This is that user metadata confirmation, that authorization from your Azure SAML, as you can see here. And all these audit logs are in JSON format. So if you're using any SIM tools like Splunk, Datadog, Elastic, Sumo Logic, you can actually feed these audit logs to those monitoring tools to enhance your compliance and awareness of what's happening in your infrastructure. Next, a short-lived certificate was issued. So as you can see in line 6 here, cert create, once that metadata was confirmed, a short-lived certificate was issued based off the schemas in my Azure AD group. And then lastly, of course, the single sign-on was confirmed. Here are the attributes from my Microsoft SSO connection with the user login event here. So with that all confirmed, I can start an SSH session in a matter of seconds. I'll log into my test server. You can see the SSH session has been created. I can check my kernels. I can check my netstat. I can echo hello world, right? You could do everything you want to do in an SSH session from our web client in an SSH session. So I'll exit out of this SSH session. And in my audit log, we'll see a lot of session data, right? So we'll see a usage report session was uploaded. I assumed Ubuntu on my Linux server with the server ID here and a unique ID for that enhanced auditing. And of course, which teleport user was on this node. Then we see a session ended with the time and details of that session. The session recording was recording with the details of the recording. And then a session uploaded to confirm that the session recording was uploaded. So we can see my session recordings. I just authenticated to my test server 1. We can play that back. And you can see all the various commands that I issued on my Linux server. Additionally, if you want more enhanced auditing than just the overall summary data of an SSH session, you can have enhanced BPF auditing enhanced on your server. So what that means is Berkeley packet filter. I can connect here as root. And if I just issue a simple list all command and exit and go back to my audit log, you'll see a lot more metadata in the audit log for all the bash scripts and keystroke commands that I issued. Specifically, the list all command that I issued. So depending on your compliance needs and how detailed auditing and compliance you require, you can have full auditing on the keystroke level of all your Linux servers. Additionally, moving over to my command line, if I just do a TSH, you'll see all the various commands that are enabled for me with Teleport locally installed. If I do a tcuttle, tcuttle is our administrative function in the command line, so you can manage the configuration of your Teleport cluster programmatically as well. So I'll do a TSH login. I'll flag my proxy server, right, my authentication gateway, and the auth method I want to use. For this one, I'll use my GitHub. You can see that login was successful, and my certificate's been generated. Now, if I do a TSH list, we can see the same nodes that I was seeing in my web client that I have access to. So let's join my stage node this time. We could do Ubuntu at, and then just the stage node I want to connect to from my command line. I'm using warp here. And you can see an SSH session was started. I can check my network, check my kernels again. And this time, I want to show you that we can actually do live session joining. So in active sessions, I see that a session is in progress, a unique session ID, which user is on that session, and which node that session is being held on. I can then join the session and monitor in real time what my users are doing on my Linux servers. If I end this session, exit out, clear that out, we'll see that I get a disconnected flag. This session is ended. In the audit log, you'll see all of that information as well. And you'll see that it was an interactive session, meaning that there was more than one user on that. In my session recordings as well, you'll see that there was 2 different Campana Marco or Marco Campanas on that node, and we could play it back the same way that we did previously. It does not matter if it's on the command line or if it's in the web client, as long as you use the teleport proxy to authenticate in, everything will be recorded and audited. Next, let's talk about application access. So for application access, all you need to set this up, along with database access, is a teleport agent or node within your private network or VPC. What this node does, we call it a teleport agent or an app service, database service, is this node has teleport locally installed with a unique join token back to the cluster, but also permissions to assume that application access or that database access through a URI script. So that URI script, when you look at add application, you put those details in the teleport configure. As you can see here, app URI. It's the same with database, except you would use a database URI. So that enables you to pass through the reverse tunnel as a teleport authenticated user and start an application session. So you can see here, now I have access to my Grafana instance. You can pass through this Grafana instance additional login with a JSON web token, but I like to showcase that you have the ability to set up a dual authentication method if you want to have extra security. With application access as well, Teleport will flag a subdomain, enabling you to use Teleport to have a public URI facing with additional security. So if I open a new incognito window and I try to access this URL, I'll be tempted to log in through Teleport. It's a really great way to harden and secure your applications without having to share usernames and passwords or extra credentials. We also have it set up with AWS Console. With AWS Console, all you need to do is have the same type of app agent within your VPC to set up AWS Console. And then in your roles, in your Teleport RBAC, you just need to set up a Teleport role with the IAM roles Teleport is able to assume. Right, so you can have these roles set up to access certain EC2 instances, RDS, read or write. And if you see here, if I use a Mac read-only role, you can see I now have access to my AWS console. But if I try to start an SSH session from this read-only role, you can see I'll get an error that I cannot connect. This is due to the fact that Teleport's only been authenticated with the read-only role, and I'm forbidden to access this. So AWS Console Access with Teleport is a way to use different SSO providers to access your AWS console. Also add additional auditing on your AWS console if you'd like to have those details about who's accessing your application, your console for this example. And then also, have that stricter policy around your cloud infrastructure. Next, let's talk about Kubernetes. With Kubernetes, there's multiple ways to deploy Teleport within Kubernetes. And let me showcase that to you here. I like to showcase the architecture before I talk about a protocol, just so there's more understanding. Again, you can have that Teleport agent, that Kubernetes service agent, to connect to multiple clusters, or you can deploy a Teleport Kube agent within a Kubernetes cluster. So for this example, you'll see that I have a Teleport agent in my Kubernetes cluster. To connect, because Kubernetes doesn't have a web client, you'll see I get the exact commands I need to run in order to update my kube config and connect to one of my AWS EKS clusters. So I'll move over to the command line. I'll do a tsh kube list to confirm I have access to various Kubernetes clusters. As you can see, I have access to all the same clusters I saw in the web client. I'll do a tsh kube login, and I'll choose my dev cluster. This tsh kube login will check my permissions and then update my kube config, so I can then issue kubectl commands. So first I'll do a kubectl get pods. I have some Nginx deployments on here. Great, there they are. They're all up and running. Next I'll get a get namespaces to showcase to you that the Teleport agent is the ability and reason why I'm able to do this. And additionally, with this kube config updated, if I want to use Lens for this, while Lens loads, let's check my audit log. And you can see that I've made 2 Kubernetes requests. What requests were those? Well, I did a get pods. You can see in line 22 this JSON. And I also did a get namespaces. So just like that enhanced auditing from the SSH server side, you can see that you can have a full audit of all your kubectl exec commands. Next, we'll go over to Lens. I'll log in with my Google. And I believe I just did a kube login to dev cluster. So as you can see, I did not need to validate who I am because my kube config has been updated. And now if I go to my pods, I can see that they're up and running. Now going back to my audit log, we're going to see a huge increase of my Kubernetes login. This is because the Lens GUI really propagates the auth server with all the activity, resource kind events, right? I'm checking all the pod health. but you can fully audit everything that happens with Teleport, even if you're using a GUI client. So I'll exit on my lens, and I'll go back to my cluster. So that's Kubernetes access. Next, we'll move on to database access. With database access, again, it's the same methodology as you would with application access, right? You have a Teleport database agent within your VPC that's going to call back to the proxy and auth server to establish that reverse tunnel, but also have that database role or user permission to access your Amazon RDS in this example. So let's say I want to connect to my single core Postgres database. To connect again, you can either use a database GUI client. You just have to upload the credentials, the certificates to the client from Teleport. And I'll use the same methodology that we just did with Lens in Kubernetes. Or again, you could use the command line interface. So do TSH database ls. And you can see all the databases I have access to in this scenario. So we want to connect to my single core sc-postgres database. We'll do a TSH login. TSHDB login. And we'll flag the name of my database I want to access. This will update the local DB config. Now you can see a TSHDB connect command has been provisioned for me to use to prevent using usernames or passwords to authenticate, but I'm just going to use my Teleport certificate that's been issued to me. So now we'll flag the user that has permissions, the specific database I want to access, and the cluster, the RDS cluster that is going to be overarching hosting this database. And as you can see, that SSL connection was confirmed. I now have access to issue Postgres commands without any username or passwords and without the use of any shared accounts. Let's just do a simple list query. And you can see within my Postgres cluster, I have a DVD rental example here. If we go to my audit log now, we should see a updated variety of events. We can see a database session was started, which Teleport user, Campana Marco, connected to which database, my overall Postgres admin database, as which database user, right, my DB admin user, and then additionally, finally, which RDS cluster did he or she finally connect to. Checking this, you have all these detailed information in JSON format as well. And you see I now have a database query audit log. As you can recall, I did a list query. So when in line 6, you see DB query, I did a select. A list query is essentially a select all database name within the catalog. And all those details are here. So just like Kubernetes, every kubectl exec command gets audited. And then with databases, every database query gets audited as well. Next, we'll move on to desktops. So with Windows desktops, the way we have and provision that access is we assume the smart card identity of a restricted service account. So what you need to do is just create a service account that has the Teleport credentials, you upload those GPOs, you deny the interactive login, you upload the certificate authority to the Windows domain controller. All we need to do is publish the certificate authority to the AD domain, and then you assume the smart card service. So I just wanted to give that overview of how this works before I go into desktop access. So now, via desktop access, I can use my administrator here, flagged in my Teleport RBAC mapping. And you can see now that I've started Windows desktop session. So let me just go to my notepad. And I'm just showcasing to you various things you can do. You can do anything you would normally do in a Windows RDP session within this web client, as well as you can see the CA that's been uploaded into the domain controller here with the service account GPOs and domain controllers. You can even clipboard and copy and paste into and out of this window. I'll now disconnect. And again, as always, that was a super easy login without any username or passwords to my Windows RDP, but also fully audited. So you could see the Windows desktop session was started, at which Windows IP, and which Windows login did my Teleport user assume, with all those domain controller information in the DNS host name. Additionally, the desktop name, that was an AWS hosted Windows Server R2 2012. The protocol was TDP. We call that TDP for Teleport Desktop Protocol. Clipboard data was sent. So just like the detailed auditing, you can see additional metadata that's been issued for these audit logs. And then you see the Windows desktop session ended, the session start and stop, how long was it, which user, right, which Windows desktop service, which domain, all of the various details that you need for enhanced auditing and logging. And then we'll see a session was uploaded. So if I go to session recordings now, you can see the icon is changed to a little RDP icon there. And you can play back everything that happened on your Windows RDP, the same way you can play back everything that happened in your Linux servers with Teleport. So as you see, I went to Notepad, and I said, hello world. Right, so not only does it make it more secure and compliant friendly to access your Windows RDP, but I also was able to start that session within seconds. In my roles, the same way you delineate all levels of access with the Teleport RBAC mapping to your Azure AD or any SSO provider that you're using, you can see I've specified that I could assume the Windows desktop login as administrator. Now you can flag this to any current domain, AD domain login that you're using, so you don't have to change up your entire setup within your Windows RDP protocol. But you do want to ensure that your users are using the proper level of permissions and the right login to assume those Windows RDP sessions. And moving on, let's assume I'm a new user in your organization and you've just added me to Azure AD. Well, with Teleport, because you've added me to Azure AD, I would have access in that scenario. But let's say you have your contractors in a different single sign-on provider like Okta. I'll start a new incognito window. I'll access my Teleport cluster. And my notional manager here says you have access to Teleport and Okta, but you're going to have to request elevated privileges to proceed. I'll go to Okta. I'll go to my Teleport Dev2 account and authenticate in. You can see that I've authenticated into the same Teleport cluster that my manager is using. However, I don't have access to any infrastructure. That's because in my Teleport RBAC, I've delineated a contractor role that forbids access to any resources, any protocols connected to my Teleport cluster. However, new users assuming that contractor role can request elevated privileges as needed. What I did in an auth connector, this time with Okta, I've tied contractor to that Okta dev group, right? So that value here matches that user group within your SSO. That enables Teleport to always be current to what your user group mapping is like within your organization from your identity provider. So now as a contractor, I've been told I can't see anything. I can't even see the auth connector or the roles because this is a restricted account. But if I go to access request, and I request access here, I'll put in my reason, access request, and I'll send that request over. In my Slack, you'll see I have a new notification from my Teleport. And you can see I have a new role request. Overview of Teleport. Standard access role. Teleport Dev 2 wants that standard access role, and the status is pending. I can then use this link. It will take me back to my Teleport cluster because I'm authenticated in this window as the administrator. I can approve it. And then my contractor will then be notified either via Slack or just by checking the cluster that this request has been approved. However, I don't have access to any of my infrastructure still. This is because Teleport uses those short-lived certificates accordingly, and we don't want managers to permit and create or generate certificates when it's not the most ideal impromptu time for those users to assume those permissions, right? We believe in the principle of least privilege, zero trust. So we want those users that have short-lived certificates those certificates to be initiated at the right time when the user's ready. So when I assume role, now you can see at the top here, my access role was assumed, and it expires in 5 hours and 57 minutes. I've set this time to live for that 6-hour timeline because as a solutions engineer, I'm always demoing Teleport to different prospective customers, and it would get really messy if I had my contractor scenario set up with long-lasting certificates. You can set these temporary certificates of elevated privileges for days, weeks, years. Doesn't matter. The key thing that matters is it will expire, and when they sign out, new certificates will get generated against that approval. And I can now access one of my test servers and get to work. If I'm the manager and I want to see that everything is going smoothly, after I approve the access request, we see all those access request details in the auto log. We see all those access requests were reviewed and approved in the proposed state. The certificate was issued to Teleport Dev 2 with that standard access from the group Okta Dev, and a session started. So I can see Teleport Dev 2 has actually already gone to work. Let's see what he's doing. Oh, okay, he's checking his kernels. Amazing. So that's how Teleport can assume short-lived access and principal least privilege with the certificates. And when I'm done with my work, just to be extra secure, I can switch back to that contractor role immediately. Let me exit out of this Postgres issue here. And again, you can integrate this with Jira, Mattermost, PagerDuty, Slack, or any service desk tool that you're using that enables a webhook. I see the user's been disconnected. And I see that session is ended. Last but not least, if you want to have multiple clusters, you say you're not using Teleport Cloud in this scenario, you want to have low latency, high availability across multiple regions, and you want to manage clusters more than just the additional RBAC mapping that Teleport has. Well, we have managed clusters here. We call them trusted leaf clusters. And all that does is spread out your Teleport cluster to be more highly available with different roles, multiple proxies, but with the same methodology as a normal Teleport cluster, just spread out across various different data centers or cloud regions that you may be using. Just a reminder that we're open source, and you can access all of these documentation in goteleport.com/docs. And the only difference with enterprise, that you want to look into, let me go down to enterprise. There's 4 main components of enterprise where you want to talk to one of our account executives or sales representatives to start a proof of concept. Right, so with Teleport open source, you only have the ability to use a local login or a GitHub login because that's where open source really lives. If you want to use anything that speaks OIDC or SAML from Okta, Auth0, Google, Microsoft Azure AD, of course, you would need an enterprise trial or an enterprise license. If you want to use those access requests workflow to enable principal least privilege and also have that just-in-time access through a service desk tool, that's Teleport Enterprise as well. And then our big compliance feature is we enable Teleport to run in FIPS mode that can enable you to achieve a FedRAMP certification with Teleport self-hosted. And lastly, we have those commercial support where we offer standard support with a response time SLA and then premium support with a dedicated customer success manager and a much faster response time SLA for certain incidents. And yeah, thank you for joining me today on this overview of Teleport. Hopefully I didn't speak too fast, but this is a recording so you could pause and play back any of the features I just showcased to you today. But remember, we're an access plane that uses reverse tunnels, short-lived certificates, and those authenticated encrypted joint tokens to really unify and simplify, but also secure and audit access to your infrastructure. Thank you for joining me today.